Hey everyone, welcome to part 9 of my Klondike and C++ tutorial. In this part, we're going to be finishing our moves.age file. So in the next chapter, we can move on to our input and output and our parsing input. So first, I want to add that function I was talking about earlier, which is going to be our update pile. And I'm just going to add it right above turn stock. And basically, it's really simple. So if the revealed index is equal to the card number, and you can kind of think about what this means. So if we have 5 cards, and the index is at 5, which means there should be 6 cards, then we're simply going to decrement the revealed, because this means that there should be the card that should be revealed, since we just removed the card that was at the revealed. And then over here, what we're doing is kind of a safe put function, because we don't want revealed to be negative, since you'll see later on when we're checking for a revealed, this will become quite the issue. So if the revealed is below 0, we're simply going to set it to 0. It's very, very basic, very simple. And then we're just going to return, since this is an inline void. So now we can remove our comments, since we're able to update our pile now. And let's start moving on to our next functions. So here is the bulk. Here is where the magic happens. We have our pile to pile function. So we need 2 pointers. We need a pile from, a pile to, and an index of the card. And actually, I'm going to rename this to card number. So let's just go ahead and Control F, and we're going to do card underscore index, and I'm just going to rename that to card underscore number, since this is just a more fitting name, I feel like. So this kind of just means how many cards are we moving in this function. So first we're checking over here if there are at least there's one card at least in the pile from, because if we're moving a card, there has to be at least one card. And then what we're going to do is add the card from index. So we want the card from index, and this is simply just going to be the pile from index at the card number minus the card number. So we're just gonna, like, let's say we want to move 2 cards and we have 5, then the index would be at 3, if that makes sense. So this is just the index of the pile from of the card we're moving, the most bottom card. And then we want the actual card that is, since that's really what we're going to be performing our logic on. And it's simply just going to be pile from pile, card from index. Very simple stuff. And then we're going to check if this index is below the revealed. So basically, we're checking if the card is a non-revealed card. Then we're simply going to return false, since we cannot move a card that is not revealed yet. And then what we're going to be doing is checking if the card number is 0, then the card rank should not be a king. So if it's not a king, since we can only move kings to blank card numbers, since that's the only that's the only legal move. If a pile is empty, the only card you can move there is a king. We're going to return false. Otherwise, we're going to find the card 2, and we're going to perform some operations there. And we're simply going to check if these are the same suit. So remember this from earlier. If it's the same suit, we shift it and we see if it's equal. So if it's the same suit, we're going to return false. Otherwise, if it's not one higher, then we're also going to return false. And then we have our move to index, which is simply our pile to at the card number. So this is the index that we're moving to. And we're gonna, and this is kind of so we can just do some very basic operations here. So the index is originally at the pile to at card number, since that's the first blank one. That's the first no card spot, right after the last card. And what we're going to do is we're going to find the card being moved, and that's simply just going to be the pile from pile at the card from index, if you remember from here. And after we set the pile 2 at the move to index to the card move, we're going to increment 2 things. We're going to increment our card number at that pile, and we're also going to increment our move to index, since now we want to move to the next card after that slot. And then what we're going to be doing is we're going to be removing a card from the pile from, and it's going to be at the pile from index, and it's going to be a new card. And then we're going to decrement the number of cards in that list. And we're going to increment our card from index now. So very, very basic stuff. And this is just to do it for once for every single card that is in the list. So we have this very simple for loop here, since card number is already initialized. And then we actually can just update both piles at the end. Because of the way things work, we already checked our revealed and our stuff in the beginning. So this will always kind of work out in our favor. And then we can just return true. And lastly, we have a more basic function than this gargantuan pile to pile. It's just a much more basic function. Similar concepts, just not as many steps. We don't have that for loop in the middle. So we have our pile 2 and our stock, 2 pointers here, and we're basically checking if. So let me actually, because I had a bit more clarification. So let's have our thing over here, and let's just put it here so we can kind of see really what we're checking for. And we can just paste that in here. So if the stock is displaying a card, then we can go ahead and run all this code. So we're going to check our card from, and that's just going to be the stock stack at the face card. And then we're going to see if we're moving to an empty pile, then the card has to be a king. If it's not, we're going to return false. Otherwise, we're going to extract the card 2, which is just going to be the face card, which is just card number -1 at the pile. We're going to see if it's equal to a king. We're going to return false. And actually, I don't think this is we don't necessarily need this 100%. So I'm going to remove this. Let me think, actually. Yeah, I think this is going to work out fine. So if the card suits are not the same, we're going to return false. And then otherwise, if the card ranks are not one higher, we're going to return false. And then similarly, we're going to extract our move from index, our move to index. But this time, we're basically only doing it once. So basically, the move from index is just going to be the pile 2 at the pile, and the move to index is going to be equal to the card from. And we actually do not need this move to index. I do not know why I had this over. And we just have to update our pile after decrementing. So very basic stuff. And I don't really have anything to test, so I'm simply just going to make it and see if there's any errors. There is a error, so let me see. Oh, we actually did need that move to index, I guess. That is kind of surprising. Nevertheless, let's try it again. And we compile with no errors. So that is it for our moves.h function. In our next chapter, we're going to be writing our main function, since we are actually pretty much completely done with our game logic. In theory, you should be able to just play a game, but we need something in the command line to be able to control when we want to display, when we want to print, and all that fun stuff. If you have any comments, questions, or suggestions, please leave them in the description comments below, and I'll try my best to respond to them. And yeah, I'll see you guys in the next part.